Okay, so let's look at another one. All right, so this time we have a car traveling at 105 kilometers per hour, strikes a tree. The front end of the car compresses. The driver comes to rest after traveling 0.8 meters. You see what I mean by physicists. Physics problems are often quite violent. So what's the magnitude of the average accelerations of the driver during this collision? Express the answer in terms of how many G's, right? That's also a common way to express things, right? So let's make this a little bit less, less cool. We'll put that in a nice orientation. Okay, so what do we do? Well, let's determine the physical scenario first. All right, so there's compression. So there's a car and a driver. Which is the object of interest? Am I interested in the car or the driver? Well, it's asking for the acceleration of the driver. So we care about the driver. So when the car is accelerating at that much, the initial speed of the initial velocity of the driver is the same as the car, right? So essentially, we just need really to care about the driver, and he traveled 0.8 meters, right? That's just short of 3 feet, right? 2 or 3 feet. When you collide, you sort of jerk forward 0.8 meters. Let's say you're going this way, and this is my positive x. Remember, you need the origin and the axis. So this is my axis. I'm going to select my origin over here. Yeah, so what else? It's moving at the initial speed is u equals to 105, but this is in kilometers per hour. That's, if I want to not write a unit, I better change everything into, so this is S, right? The displacement is going to move that far. I better change everything into SI units, or the standard SI units, or the base SI units, which is meters per second. So how do I do that? Well, we can change it using the standard way. So kilometers per hour, right? How many so 1 kilometer is this is my way of doing it. You can use whatever you like. 1 kilometer is 1,000 meters. So I just replace kilometers with 1,000 meters, or 10 to the power 3. And also, how many seconds is in an hour? So there's 60 minutes and then 60 seconds. 60 times 60 is 3,600. So 3,600. So yeah, let's keep that as 1,000. That will do. 3,600 seconds. Right. So overall, I get 105 times 1,000. Well, this just simplifies to a 3.6, right? If I divide by that. So, or what you can do is just times 1,000, divide by 3,600 meters per second. So that's my preferred way of doing it. So we will have 105 times 1,000 divided by 3,600, and that will give me 29.16. We're going to go with 17, okay, meter per second. Okay, so the initial speed is that much. The velocity is towards the right. Okay, so everything is in SI units, all right? Can get rid of this. And then what else? Yeah, good. I think that encapsulates most of it. Now let's move on to write out our SUVAT variables. So the S is plus 0.8. The U is, I'm going to define this as positive, right? So it's plus 29.17. The acceleration is my aim. And do I know the time? I don't know the time. Now, do I know the final speed? Not obvious, right? It didn't say. However, if I just have two out of 5, I couldn't possibly find everything I need. I need at least 3 out of 5 in order to solve for other things. But there is a V, there is a final velocity. It's just implicit. It says the driver comes to rest. So look for these keywords. Rest means the final, let's shrink that a little bit. The final velocity is 0. Okay, all right. So now I need to pick an equation. Which one should I pick? I definitely want an A because I need to solve for it. And I want to make use of whatever I have, right? So I don't care for T. So let's pick an equation without T. And if my memory serves, it's V squared equals to U squared plus 2AS. That doesn't have a T, right? So now that you remember the equations, you can just quote them like that. And now that's step 3. You can just chuck in everything you need. So 0, 29.17 plus 2a is exactly what I want, and s is 0.8. Okay, all right, so what do I want? I want a, so we can move that to the other side, minus 29.17 square. So I'm going to move this to the left and then divide by 2 times 0.8. All right, so let's ask our calculators. So I have minus 29.17 squared divided by 2 times 0.8. Remember brackets if you have calculators like this. So that will give me minus 531.8. All right. All right. Oops, sorry, you can't see the calculator. Yeah, you can trust me. Yeah, you can verify yourself even better. Good. What's the units? Meters per second square. All right. Yeah, that's quite a large number, is it? How much G's is that? Well, so I want to express that in G. So let's divide that by G. So because if I have, if I do, for example, G is 10 meters per second squared. Let me just roughly round that. If I say the acceleration equals to 2G, that means it's 20, right? If it's 3G, it's 30 meters per second squared. So what you want to find how many G's is taking this and divide by 10, right? Divide by 10, basically divide that by G. So let's take this 351.8 divide by G, okay? And you can get how many G's that is. Before I do that, right, that's just a calculator. I want to mention we have a minus sign here. Does that make sense? Well, my positive is this way, right? So what does that mean? It means I'm accelerating this way. Does that make sense? Yeah, because I'm slowing down. I had the initial speed here, and it's gonna, final speed is gonna be 0. So I'm decelerating in some sense, right? Or in other words, accelerating in the opposite direction from the motion. So this is an example of deceleration, right? So you can check, I'll do that as well. Take that, divide by 9.81. And I think, so if I divide both sides by G, so A divided by G, I have minus this divided by G, right? So A over G is equals to minus 54.2, right? And that means therefore A is minus 54.2 G, okay? The G already includes the meter per second square, so I don't have to be redundant and write an extra one. So you always hear people just say how many G's, right? You don't need the how many G's meters per second square like that. All right, 54G in the negative direction, that's a lot, right? I don't think this poor folk can survive this. But the violent situation and tragic end aside, I think we are very happy about how to solve these equations. All right, so try to reproduce this and see if you can. Let me know if you have any questions.